about a couple of years ago, we tried to do how many of you have done forensics before? Any type of digital forensics? Oh, you guys have, is there a class here? Who's teaching? There's a brand new one. So you guys took the class? How do you guys use volatility?
Yeah.
Oh, you already have. So,
With
okay.
Dr. Lynn,
What's that?
with Dr. Lynn.
New faculty. Okay, so you guys are probably gonna be ahead of the game. You're probably seen a lot of the plugins that have been used here, and you guys are gonna be fine on that. For those of you who haven't, I'm gonna prep this really quick. So you're not gonna be a digital forensics expert coming out of a workshop, even coming out of a course. A lot of the work that happens in digital forensics is years and years of experience working with operating systems. You have to understand, the more you understand about operating systems and networks, the better you're going to be. You're gonna see a lot of dumps in the screen with a lot of information. Half of it won't make sense to you. It takes time to learn what, if you haven't taken a class, even on system administration that teaches you the CLI for Linux, you're not going to be familiar with some of these things. If you haven't taken an operating systems class, which in some universities is now optional, they give you an option to know compilers and an operating systems class, you're also not going to be familiar. And so, if you've never taken an OS class, I highly recommend it if you want to stay in cybersecurity. I can't imagine doing cyber without having an operating systems course. Don't worry about that. We're going to get through it. And just so you know, when you start doing digital forensics, you're kind of drinking from the fire hose when you first start. And so what happens is, over a period of time, especially folks that work in digital forensics, they have their cheat sheets, right? And they know their algorithms and the techniques and the processes that they follow. And so a lot of times when they go into a scenario where they need to do the analyzing of certain of a situation, right? Whether it's the RAM, whether it's the disk, they already have all the instructions. We're going to go through this first, this second, this third, and they also have access to really high power tools, right? That we don't, right? And we're not going to spend all that money on. So just to give you an idea, I just wanted to put that into context because I get a lot of students that come into the class, and we teach digital forensics only for a third of my class. A lot of students come in thinking that this is like CSI, right, on TV, and they're going to go in there and figure out who did what to whom, and it's not like that. Digital forensics takes a lot of time, takes a lot of experience knowing about the system. It takes a lot of hours, sometimes going through log files to try and see what happened to put things together. But on the flip side, the salaries are pretty high for people who want to do digital forensics, right? So it depends on what you want to do. So having said that, a little quickly about me, I go by Clem. My students still call me Clem. I don't go by doctor or anything like that. I'm very informal, as long as you're respectful, and that's good rule for everybody. I've been a professor at Montana State for about 15 years. Before that, I spent 16 years in industry working for Hewlett Packard, working in the kernel for HPUX. And then I made a switch to Intel. I actually didn't make the switch. Intel, HP sold our lab to Intel, and one morning I worked for Intel, and I was working on the Itanium microchip, if anybody ever heard about the Itanium microchip. I have joint appointments with Idaho National Labs and the Pacific Northwest National Labs. So I work with those guys very closely. We have awards and grants that we work with them, current with both. And I co-direct the lab with another professor, Dr. Reinhold. Just so you guys know, Dr. Reinhold comes from an ecology, hydrology background, but she's a data scientist, right? And so, and this is just to give you guys an idea of how cybersecurity and computer science, as long as you have an analytical mind, who cares if you're math, if you're, whatever field you come from, if you have an aptitude for solving analytical problems and you like doing this type of work, you're going to thrive. And she has, right? And so she's a co-director in our lab. We get funding, current funding from multiple places. We currently have 8 PhD students, 5 masters, and we have lots of undergrad students that come in and out and rotate through our lab. We also have professional staff, program managers, professional engineers that work with us in the lab. So a little bit of an outline of what we're going to talk about through the next couple of hours here. I'm gonna talk a little bit about some introduction to digital forensics. I'm gonna go through some slides, and then what I'm gonna do is I'm gonna switch to the exercises. I'm gonna do all the exercises in here so you guys can actually see what I'm doing. The reason you guys, we gave you instructions to run the exercises on your own is so that if you have an interest to continue to pursue some of this, you can go home and you can start playing with some of these tools. Okay, but all the exercises I'm going to do on the screen, and you guys are going to be able to see all the exercises without having to worry about, you know, hey, this command doesn't work, the syntax doesn't do what I expected, etc. Right? We're going to talk about conducting the investigation, planning, preparation, reporting. There's lots of different types of forensics out there. Right, so this forensics, and I gave a workshop on this a long time ago on this forensics. I'm not doing that this time because this forensics takes a lot of the images, take a lot of space, and it took forever to try and upload some of those images while we were here doing the workshop. And so we decided not to do that. And some of the best tools are not open source. And so I decided not to do that this time. And this time we're actually going to focus on memory forensics. Okay, so this is what you call volatile storage, right? So stuff that if you turn the power off, stuff disappears, right? So what's in your memory? There's also network forensics. There's window registry forensics. There's all sorts of different forensics that you can focus on. Okay, so a little bit about digital forensics, right? So there are lots of definitions out there. This is one that I prefer. Collection, analysis, and interpretation of digital evidence. Okay, that's basically what it comes down to. So there's a lot of things that you have to be aware of when you're, and we're going to talk about some of this when you're doing forensics, meaning if you're in a case, many companies do this, and there's a lot of consulting companies that go and triage when something happens at a company says, hey, we're the victim of ransomware, or somebody's infiltrated our network. There's companies that go and triage this, and they go on site, and there's lots of things that they have to keep in mind, right? You can't tamper with evidence. You have to keep a log of everything you do. You have to understand every person that's working on this. If they collect evidence, you have to have a log of who has that memory stick, maybe, that has that evidence. If you don't follow those rules, it's not admissible in court, right? And so there's a process, and you have to keep tabs of what's the version of the tool that you're using, what time of the day did you do things. So everything has to be reproducible, right? And so that's why it's an interesting, it's not just about the technology, but it's also an overlap with law, right? So it's a relatively new, still relatively new field. So any data so digital evidence, what is the evidence? Any data that's stored, transmitted using a computer that supports or refutes a theory of how an offense occurred, or that addresses critical elements of the offense, such as intent or alibi. Okay? Evidence is information and data that's of investigative value that are stored or transmitted by a computer. Digital data that supports or refuses a hypothesis. And so I can't overemphasize this when you tackle digital evidence, digital forensics cases. I can't overemphasize enough that using the scientific method to approach a case is extremely important, right? So, does anybody, what's the scientific method? Anyone? Just give me a guess. What is the scientific method? Anybody? A non-engineer, somebody that comes from physical sciences. What is the scientific method, the scientific approach to doing something? What is that? You guys are computer scientists. You should know what the scientific method is.
So we start with the hypothesis.
Okay. You start with a hypothesis, and then what do you do with it? What's a hypothesis? Anybody, what's a hypothesis?
It's how you think something will happen.
Yeah, it's a statement of how you think the world works, right? That's a hypothesis. Okay, then what do you do with a hypothesis?
Try to prove it. Whether it is, you decide your methodology and you try to gather data
Okay,
and you try to understand whether your hypothesis is true. It can be proven with some scientific
okay,
methods.
okay.
And then you can come out some solutions or some suggestions and you evaluate your findings.
Yeah, I probably, I don't like the word proving. I like to use the word statistical significance more than proving. There's always a chance something may not, there's always a chance that something may happen by chance, right? Even if you have 99.999%, certainty that something's happening, I always prefer to say the statistical evidence that suggests that something is unlikely to occur by chance, right? And so you use statistical methods on your data to try and show evidence to the contrary, your null hypothesis, which is typically status quo, nothing changes, or right, or evidence to support an alternative hypothesis, right? So hopefully you guys did this in high school, right? When you're dissecting a frog, right? What's all of this, you do a hypothesis, you go through that process. All right, anyway, engineers tend to be a little bit jaded. They're disadvantaged because engineers, we're taught, especially computer scientists, we're taught how to build stuff and how to engineer something, as opposed to how to do true science, which is here's a hypothesis, and then we try to look for evidence, we collect data, there's different techniques to do that, right? So that is something that I always come across in grad students because they come from an engineering background. And then they can build stuff. Hey, Clem, I can build this, I can do this, I can do this. Okay, but can you validate that? Can you show me what the process for that is? And that's where students who come from maybe the humanities or from physical sciences, they're typically, they've been, taught how to do that from the very beginning. So, if you haven't done any of the scientific method processes before, you will when you go to grad school. All right. So what are the different types of digital data? Computers, laptops, desktops, anything, right, that you turn on. You have hard disk drives. You have random access memory, human interfaces, communication systems. There's all sorts of different things. Anything that's embedded in computer systems, right? You have devices, smart cards, SIM cards that are on your phone. Anything like this are types of digital information or digital data. Okay? So digital evidence processing. So this is critical to follow an appropriate process and procedure when you're collecting and processing digital evidence. Okay? It's paramount when you work, any company that does digital forensics, they're going to put you through that first. Not following any of this puts your investigator at a legal risk collecting without authorization, okay? So anything that you haven't followed a proper procedure for, you're gonna get in trouble and it's probably gonna be inadmissible in a court of law. And so you're just not gonna be able to do that. So there's a lot of nuances associated with that you need to be aware of. So context is critical. It's always important to understand the why is it that you're investigating something, right? The timelines, when did you collect the information? When did you enter the building? Who did you talk to at what time? All of this is just like following any case, right? Any legal case when you're looking for evidence. And all of this is going to directly influence what you collect and how you process it. So there's corporate issues versus legal issues versus law enforcement issues that you also have to be aware of when you do digital forensics. So it's an interesting field. It's a little bit different. There's a cross-pollination between that and a lot of the computer science that we do. So two aspects here to look at. And today, what we're going to do, the exercises that we're going to do today are going to be on volatile storage. So basically on the RAM side of things. And so for those of you who went to download, who went to that website to download the memory dump that I put in there, okay, that is a dump of memory from a particular computer. Okay, so somebody went in, the computer was on, bodies right next to it, right? And then you capture, the memory that was on that computer at that point. Okay, so what are the principles of computer-based electronic evidence? There's some principles that we need to be aware of, right? So no action should change the data ever, right? As soon as you change any data and you've changed the situation, you've changed everything. It no longer represents what you're looking at. If you're accessing original data, then hopefully the person is competent. And you have to be able to explain relevance and the implications of any actions that you take. There has to be an audit trail or a record of all the processes that are being applied, okay? And then a person that's in charge of the case has the overall responsibility for ensuring that the laws and principles are followed. Okay? And there's different standards that are coming out. Law enforcement, the FBI is coming out with different manuals and different standards that are required for you to follow when you're doing digital forensics. Collection. This is typically collected through software or hardware tools. Some of them are open source and some of them are gonna cost money, right? Hardware tools are typically used when the device is physically in the possession of the investigator and provide power to an interface to access the target device. So a lot of times you are allowed to take, some of the hardware with you. You're gonna take it to a lab and you're gonna plug it into different things. Sometimes you're recovering information from a disk, right? And so there's a lot of tools that allow you to do that. The implications of the choices, right? On the principles of computer-based evidence exchange. And so here's we're gonna talk a little bit about those principles. So here's a couple of examples of volatile versus non-volatile artifacts, right? So volatile does not persist across power cycles. So if you're going into a digital forensic scene and something is turned on, you do not turn it off. That's the number one rule. You never turn anything off, okay? Examples are gonna be RAM contents on a computer. Non-volatile, this does persist across power cycles. For example, the hard drive, right? You take the hard drive out of the computer. Okay? So that's at a very high level. Okay. When you're doing non-volatile or you're doing a disk capture, right? This could be a hard drive disk capture. It could also be a virtual disk. Okay. So you're basically creating a content or a copy of the contents of the hard drive, and you're copying that to a file for analysis. Regardless of how you're doing that copy, right? You have to know what tool are you using to copy the contents of that hard drive onto a file so that you can examine it. Because some copy techniques add metadata to some of the information. Is that changing the data, right? So you have to be aware of that. The disk capture can be done physically, right? You can connect to the disk, or you can do it virtually. You can be somewhere else, and you'll be able to collect that data. Regardless, you have to document all of this. Okay, so let's talk a little bit about these principles of digital forensics. So the principle of certainty. We're almost never certain. Okay, this is a protected term that must be used with extreme care. Certainty is like saying, there's no doubt. This is 100% sure, and nothing is ever 100%, the case. Okay, we cannot be certain of what occurred at a crime scene or any other situation when we only have a limited amount of information. And remember, you're not going to have all the information when you walk into the crime scene. Typically, you're used in a case as somebody that supports a larger case. Okay? And that's typically what happens with digital forensics. We can present possibilities, hypotheses, and the evidence and information that supports or refutes those hypotheses. Okay? So this is Locard's exchange principle. Okay? And basically, what this says is that anytime there was an offender and a victim, and anytime you have a physical crime scene and a digital crime scene, there's always going to be some kind of evidence transfer across those things. Okay? There's always the potential to have tainted information that comes across one or the other, or there's potential to have evidence that, you wouldn't otherwise have had the offender and the victim not interacted. And so when, you know, you may be really good at covering your tracks, but there's always something that's left behind. And so this goes back to Locard's exchange principle. And this is something that goes back to law enforcement many years before we had computer science. So, what are the characteristics of evidence? There's typically, there's class characteristics and there's individual characteristics. At a class level, similar traits between groups of items. We have common traits. We have examples like file format characteristics, right? And these are class level type characteristics. Individual are going to be things that are tied, that are specific to an individual. In this case, the MAC address, right? It's an individual example of digital evidence. No other computer is going to have that same MAC address. Okay, so there's different types of characteristics. There are taxonomies out there that describe a lot of these things. Again, we're not going to go through all of these things here because there's no time to go through all of these things, but at least, you know, to give you guys an idea of what we have here. The principle of forensic soundness. So this is how evidence was handled. How was it preserved? Was it examined? And there's two key concepts here. There's the non-modification of evidence and there's documentation, right? So this is something that obviously it should be self-evident. And then the documentation, what is the timing of events, the tools that were used, the methods, what are the hash values for everything that you had? So when you collect something and if you have a hash value for it, somebody else should be able to, you know, compute that and make sure that it is indeed seeing what you actually saw. So there is, you know, the integrity of the information that you're looking at. Authentication, this refers to the integrity of the data and the records that are being analyzed. So you have to be able to show that the contents of the records are unchanged. You have to be able to make that case, right? When you go in front of a court, you have to talk about the information in the record and that it originates from the actual source. And then there's extraneous information, such as the date of the collection, whether the record is accurate or not. All of this is part, again, of making sure that you're building a good case. The chain of custody is also important. They do a lot of this now with digital technology, but there's still a lot of paper trails that are out there. This is the documentation that proves the continuity of the possession of evidence. In other words, if you see people putting something on a little Ziploc, right, when you're in the crime scene, this is similar with digital information, right? You're still going to put it on a Ziploc if you're taking something out of a crime scene, even if it's a hard drive. And there's both a paper trail as well as a digital trail now of how they document a lot of this information. Okay? Paper trails are still used a lot by the police and by the FBI, even if you go into a digital crime scene. Okay. Evidence integrity. So this shows that the evidence hasn't been modified since the time of the collection. We use what are called message digests or hash function. You guys should all be familiar with hash functions, right? To perform that work. They always produce the same output for a particular input, right? And then most practitioners, right, most digital forensics folks use standards. You're never going to see, do not ever invent something, even if you think it's better than something else. You have to use the standards, okay? It has to be vetted by the community, especially if you're working in digital forensics, okay? And there are other tools that, you know, support MD5 or SHA-1 or whatever, but always use a standard. Okay, repeatability or replication of the work. This is critical. Okay, so it's just like the scientific process, right? When you write a paper, when you write a journal paper, you write a conference paper, there's always a section called methodology or methods, right? In that paper, that part of your paper has to have enough information in it so that somebody else can replicate the work that you did, right? And that's the basis of science. If somebody cannot replicate the work that you did, how am I going to know that what you came up with is correct or wrong? I have to be able to replicate, that's the basis of science, the scientific approach, right? And somebody else should be able to dispute what you came up with, and that should be welcomed by you as a scientist. You should be able to have other people replicate your work and say, hey, I did your exact same study, but there were a couple of things that came back different. Or everything came back totally different. And then as a scientist, hopefully you check your ego at the door, right? And you're like, okay, what's going on? Right? That's the idea. And so repeatability or replicability of the work is critical. Okay. And so it's critical that for any given piece of evidence, the process by which it is analyzed and the information from that analysis is repeatable. And so this allows people to do independent verification of the work, right? Objective work. Okay. All right. What are some of the dynamics of evidence, right? The real world is imperfect. We know that. Any event that changes, relocates, obscures, obliterates, regardless of intent, can definitely happen, and it probably will. And you have to be able to document that. It doesn't mean that the evidence is not admissible anymore, but you have to document that if whatever it is that you did had any effect, right, on that particular information. The time frame from the time the evidence is transferred and the time the case is actually solved, it's also, part of the evidence dynamics, and you have to keep track of all of that information. The case is still active during that particular period of time. Okay, DFRW, this is your digital forensics research workshop. You can go to this website, and there's a lot of information on digital forensics there. The community, what they do, there's a workshop, what are the types of papers that people are publishing. It's really fun to go to that, and if you have the time, and keep track of some of the things that are going on. And then DFIR, this is digital forensics. This is the incidents response conference, and it's focused on incident response. From what you're going to get here is a lot of first responders that get to a particular place when something happens. So one of the more classic, which is before digital forensics became more in vogue. Recovering the black box from an airplane when it crashes, that's a form of digital forensics, right? When the ship sinks, that's digital, that you're recovering the black box from those events. That's digital forensics. Okay. Okay. We're almost there, and we're going to start doing a couple of exercises so that you guys can see this. So how do we capture evidence, right? So there's volatile and non-volatile. We talked about this. So volatile has to be captured while the system is running. Okay, faster you can do it, the better. A lot of times you need permission. And so there are tools that can bypass that permission, but you're going to need like administrative permissions or a way to do the actual dump of some of the memory. And sometimes you need permission to do that. Non-volatile, you can capture that from a running system or an offline system. You need to check on what the purpose of the investigation is to determine the best way to capture that non-volatile data. Okay? When you're capturing non-volatile evidence, the interaction with the data storage device, when it's powered off, they really typically you have to figure out how you're going to access the data and how you're going to power on the device. This takes quite a bit of skill. It's not just as simple as turning something on. Even when you take it back to your lab and you're trying to turn something on, you could potentially, cause a short, do something to it, and you could end up, damaging the information that's in that particular device. A lot of times it starts with low voltage turn on of systems, but there are different techniques associated with this. All right, so the physical disk capture, there's two things here. There's pros and cons associated with this. When you're capturing a physical contents of an actual drive and you have that drive in your possession that you took from the crime scene, okay, you can get a lot of the deleted files, right? If you work with Linux, right? The Linux operating system, when you delete a file, you're basically just deleting an inode in the operating system. The contents of the file are still in the actual disk, right? It's just a pointer, right? You deleted the file, that pointer points to the free space, but the contents of the file are still there, right? And that's managed through something called inodes. But you can get all that information. You will be able to parse the entire raw disk and data structures. Again, so you can go through all the ones and zeros in that disk and you can get all that information. What are the cons? You're also capturing used and unused disk space, but in a way, I prefer that because you're getting a lot of information. Very time consuming, requires a ton of space, and this has huge output files. When we tried to do this workshop first a couple of years ago, this was a big problem when we were trying to do the disk forensics. Okay, and so that's the reason I'm not doing it here. Okay. A logical disk. Logical contents of a particular drive. Okay, so what's a logical disk? Okay, this is, think of it as a device that provides, it's an area of usable storage capacity that can span more than one physical disk. In other words, a logical disk can be made of segments from different physical disks. Again, that's a logical disk. So the capture is going to be a little bit different. The pros is that it's going to give us all the files from the operating system's point of view, because that's what the operating system uses to think of that particular logical disk, right? You've mounted that from somewhere. It's much quicker, it's much smaller output files to take a look at that, right? The cons, you're not going to get the unused disk space, right? Anything that was deleted is not going to be in there, and there's no chance exactly of recovering those deleted files. All right. So what about capturing the volatile evidence? Volatile evidence is non-persistent when the power is lost to the device. So you always leave things on. When you get to the crime scene, if something's on, you don't touch it. Right? The main component that affects us is any system with a RAM component, which loses all the contents when the system is powered off. So that's one of the reasons you want to keep all the systems running. The evidence requires that you interact with the running system. This is typically, if you're not on the site, you can use a remote SSH using tools like volatility search. So we're going to use like volatility here to examine the contents of something that has already been captured, right? So what you guys have on, if you downloaded it, or you can download it later, this is something that was already captured with volatility search. Okay, this you have to pay for. Okay, if you want to capture the contents of something, you have to pay for that tool. Okay, you need to be careful that you understand what you're capturing. Okay, in some cases, you need administrative access. You could be creating new files on disk. You can fill the disk and crash the machine at all, and then you lose all of that information. So this this is the local security administration system, something in Windows. So you can actually trigger an exception when you do a memory access, and you can lose all that information. So you have to be careful when you're doing a lot of these things. Okay. Network forensics. Okay, has anybody ever done network forensics before? I mean, you probably use Wireshark and Snort and some of those tools, going around. There's a lot more sophisticated stuff out there now. You don't actually even have to tap onto a line when you put the cables through it. You can actually do this with radio frequency now, and which is really interesting, and there's a lot of security consequences associated with that. If you like working with the DoD, this is really fun toys that you're going to get to experience how you can sniff packets without actually having to probe something in. You can capture the network information in the packets by putting a device like that. This allows all the incoming traffic, the RX and the TX, to be sent on an additional interface. And you can, a lot of this can be leveraged to access the processes that you capture on traffic. So a lot of the tools, you're gonna get this in Kali Linux. There's a lot of tools like Wireshark, like I said, Snort, Suricata. There's a number of tools that allow you to play with this already. The network's forensic capture, you're typically talking about a full packet capture, not just the metadata. You can monitor ports, like it could be copper or fiber. The traditional capture format, if you've never done this before, is called a PCAP or packet capture. And so there's a whole bunch of, like I said here, there's a number of tools that are available here. We're not going to cover network forensics here, but it's a different field and it's a different area that is used, that can be studied. What are the pros? You can basically do a full capture of everything that's going across the wire. You can include files, non-standard protocols, lots of stuff. In industrial control systems, you've heard a couple of talks about industrial control systems today. You have to be careful. You can't just go out and tap into a network that uses some of the old industrial control system protocols, because a lot of them are real time. And just the fact that you introduce a tool to try and monitor that causes a fault on the actual network. And so it's really interesting with industrial control systems with real time, the very fact that you're going to try and tap it could cause the network to fail. And so there's different ways in which you can do that. Okay. The cons, you typically have to decrypt inline, so man in the middle traffic. Okay, lots of potential attacks in that. There are newer versions of the transport layer protocol versions that are making passive decryption really, really difficult. And then the encryption is not always possible. And what's making this harder and harder and actually less relevant anymore is a lot of the cloud. And so the introduction of the cloud, and it has become so much more pervasive in our environment, is really forcing us to change the way we're doing a lot of the network forensics anymore. Okay, I'm not going to go into that, but that it's not just the peer-to-peer networks anymore. We used to have the traditional traffic going back and forth. Now the cloud is making things actually quite difficult. What are some of the other? So the reason and other reasons why capture is becoming less and less feasible is the amount of transmission and storage limitations that are going across the wire. With higher and higher throughput across the network, it's making it extremely difficult. But there's low storage requirements on some only when you're capturing metadata, which it's possible. And the processing overhead is also a challenge when you don't have the right hardware to offload, especially with some of the specialized drivers. There's a ton of drivers out there right now that make this difficult. So one more slide before a couple of exercises. So network metadata, what's making some of these things difficult? The cloud, typically NetFlow data, AWS, VPC flow logs, they're difficult to read. And on-premise, the Suricata is the most popular intrusion detection system. This is typically collected by some of that tool that I showed you with that picture, with the NetFlow collector. There's other tools that allow you to collect just protocol metadata for some of the protocols. You don't need to collect all the information sometimes when you're trying to just find out who's talking to whom. Okay, so let's do an exercise here. So what I'm going to do. Ooh, this got big all of a sudden. Okay. Let me. All right. Let's see if we can. Okay, there we go. So there's two volatilities. The guys that took the class in volatility, do you guys use one or the other version? Version 2? Do you guys use volatility 3 at all? No? Maybe. Okay. Just do it. Okay, so there's two versions of volatility right now that I've used, volatility 2 and volatility 3. I wouldn't say one's better than the other, okay? The two versions of volatility, this is a tool that allows you to examine a memory dump, okay? Have different plugins, and the plugins do different things to examine what's in that memory dump, okay? The plugins do things like, give me all the processes that were running in memory. What are the files that were, in the system or in memory at the time this is, we collected all this information? Who are the parent processes of something? There's a plugin that is called Malfind, which allows you to look at what are the processes or the files that have been flagged as known to have a vulnerability. And this plugin is going to tell you the names of those things. You can dump a lot of the files that are captured in that memory dump. And you can say, hey, dump all of the files that are in there and put them in a separate directory so I can go and look at those things. So there's a number of plugins. And the more you know about those plugins, the better you get at investigating how some of these things, what is the order in which I'm going to run this when I start to investigate, a new memory dump. So one of the things to know, and what I have here, volatility 2, I'm going to run it with Python 2 or Python 2.7. I know this is kind of hard to read, but basically there's the way it works. You call volatility, there's a -f command, the -f parameter or option says, what's the file that we're going to use, that we're going to investigate? And I put mine in a directory called memory captures. Here's lab2. And here's the name of the file, and it usually ends in a .vmem or a .mem, okay? And that's basically the capture that I'm looking at. And then after that, you're gonna give it the name of the plugin that you want to run, okay? Again, you don't have to become experts on this. I'm just giving you an idea of how this process works, okay? So what am I doing here? Volatility 2 requires an understanding of what is it that you're examining? What is the dump that you're looking at, that memory dump that you did? What was the format in which I think this was put together? And so there's this plugin called image info. And what it does is it examines that memory dump and it tells you all the suggested profiles, what I think it is where that memory came from. And so it'll give them to you in an order. So it thinks first, it thinks it's a Windows SP1 64-bit system. Second, it looks like it's this thing. Third, it looks like it's this thing, and then it keeps going this way. And so most of the commands in volatility 2 require a profile. And so I typically run this image info plugin first. I pick the very first profile out of the possible list, and then all the other commands that I run in volatility, I say, I'm going to use the profile Windows SP1 x64 to examine that memory dump. Because there's certain data structures and a certain format in which things are formatted by Windows in this case, right? This is a pain to do, in my opinion, with volatility 2. Volatility 3 did away with that. And it automatically guesses what is the format in which the system dump, what is the format of the image that we're actually looking at, okay? But the reason I put this here is because when you run volatility 2, there's a number of plugins that are not in volatility 3. And in volatility 3, they have a number of plugins or tools that are not in volatility 2. And so as a forensics analyst, you need to have both tools available to you. Now, the format of the memory dump is different for both tools. So volatility 2 also has an option and a plugin that says, take the image that I'm looking at and dump it in the format that volatility 3 can read. So it's nice. We can do a lot of these things. Now, there's a website. If you work in this space, there's a website called, or a blog, whatever, volatility 3 cheat sheet. And this was for people who were using volatility 2 first. And what it does is it's really helpful because whatever command I'm running in volatility 2, I go to volatility 3, and it'll give me the counter example using volatility 3. And it's not for everything, it's only for the ones that are paired up, but there's, this is a Venn diagram, right? So here's the commands that both of the volatilities run, but some are run by volatility 3, some are run by volatility 2. This is the intersection between the two, and this is the different format in which I do things. So it's a nice, website that, cheat sheet that allows me to look at those things. All right, so I'm gonna be back here. So the first thing I wanted to do is, all right, so I'm gonna go in here and I'm gonna clear this and go to the top so you guys can see this. Hopefully you guys can see this a little bit. I'm not sure I can make this any bigger. I made this as big as I can inside this virtual environment, and I can't get any bigger, but I'll tell you guys what I'm typing in here. So the first thing I'm going to do in here is I'm going to use volatility 3. So I'm going to use Python 3. Okay, I have both Pythons installed in this system. So I'm going to use Python 3 because that's how volatility 3 runs. Okay, and then I'm going to say, okay, go to volatility 3. Here's the Python script. Okay, volatility. I have to give it a file, right? So where's that file? Where's that image, that memory image that I collected? Okay, so the first thing I'm going to do is I put this in memory captures. I think I called it lab 1. Memory.mem. Okay. And then I need to give it a plugin. And the plugin that I'm going to give it in this case is going to be PS list. PS list just says, what are the processes that were running the operating system that was running at the time I captured this particular image. Okay, so when I run this, and there's the error. So what did I miss here? Oh, Windows, sorry. There you go. Windows.ps list. Okay. Okay, so now this thing is going through and it's basically scanning the memory layer using, some of the internal tools that volatility uses. And it's just going through it. It's going to take a little time, depending on what kind of virtual machine you're running, who's using all of this, and I didn't have to give it a profile, okay, in this particular case. So it's going through this, and guess what? This is giving me a dump of all of the processes that were running at that time. So as an investigator, I'm like, hey, what was running on this machine? Yeah. Okay. I don't think don't want to mess this thing up because it's, it doesn't. That's the best I can do. It doesn't go any higher than this. Let me see if I can get 200% or 300%. That's as high as it goes. Sorry.
Where did you say the documentation for this?
So all of the documentation is, so the instructions.
It's a follow.
If you guys want, I can give you a cheat sheet of all the commands that I run. And I can give it to James at the end, and you guys can run them on your own if you want. Okay, I'll do that at the end of before you guys are done with the workshop, you'll have all the commands that I run. Okay, I don't want to focus too much on the syntax right now, because I want to make sure you guys get the gist of what digital forensics is about, right? So what I'm doing here is I'm dumping all the processes that we're running. Why do I want to do that? Why would I want to dump all the processes that we're running? Anyone?
If there's any like suspicious processes that
Yeah.
we're saying, look at the last one that could have like caused it to be there.
Yeah, exactly. Somebody may be running something that's really weird, right? Now, it's unlikely somebody's gonna call their process, hacker.exe. You have to be pretty silly, right? But they're probably gonna try and, call their process something that's already part of the operating system. So there's other plugins that we're gonna need to look at, okay? So anyway, and here it gives you the process ID and the parent process ID, right? So the operating system in Unix, for those of you who haven't taken a class, every process that runs in the operating system gets a process ID. And it's spawned by a parent. Sometimes a parent spawns multiple processes, right? And sometimes somebody may be like Apache, for example, right? Apache runs one process ID, and every time it's doing something different for different requests, it'll spawn a different process to carry out that request in an asynchronous manner. So there's different ways in which this is tracked, but Unix in general uses processes and process ID. There's a data structure, if you look at the source code associated with the process ID, okay? If you take an OS class. So, okay, so we have all that information. What's another thing that we can run? All right, I'm gonna run another command called netscan. Okay, what does netscan do? Netscan is going to go out there and look at the processes and look at the open ports that are in this machine. And maybe what I want to do is I don't want the output of everything, but does everybody know what a pipe is in Linux? Just say that. If you don't know, that's fine. Just does anybody not know what a pipe is? Just answer, okay. So a pipe in Linux says, run this command, and I put a pipe which says, take the output of this command and use it as input for the next command in the pipe. That's all it is. Okay, so I'm gonna run this command. I'm gonna actually clear this. Let me put it at the top. I'm gonna go. Hold on, guys. This is freezing here. Give me one sec. Okay. So this is running right now. I wanted to run it at the very top here. Hold on. %, 87, 90. Okay, so the netscan command is running, the scanning is finished, and now it's going to output all the different information with the IP addresses of the processes that we're running. Okay, so what's one thing that I can do in here? There's too much information in here. So one of the things that I can do, see if I can terminate that. I'm going to run the same command. Let me go to the top of the screen so you guys can see it. I'm going to clear this. Okay, I'm going to run the same command, and I'm going to pipe it through grep. Grep says search for the following string, listen in. So now what I'm saying is take the output of the netscan and only give me the ports that are listening. Okay, so as an investigator, I want to see what were the open ports that were in the operating system. So I'm going to run that. Okay, and it's going to look at the output of the volatility, and it's only going to pipe this and say, just give me those lines that have the word listening in it. Okay, so guess what? Now I have a whole bunch of ports. Here's all the different processes, the names of the processes, SVC host, LSAS, right? All of these processes, these are all the ones that are listening. Listening ports are the ones that are likely to be attacked. Okay, so I'm like, okay, I have a little bit more information. Again, this comes with time and understanding of how the operating system works, right? So what's another thing that I can do in here? All right, and we're going through some examples here, right? So these are just examples of different plugins. Let me clear this. I'm going to run another called PS3. PS3 is another plugin. Okay, and this plugin gives me the same information that the process list gives you, but it also gives you the parameters associated with each of the commands that may have been running in the system. So guess what? When I look at the output of this, the first thing that jumps out at me is that somebody was running, if you go to the top up here, somebody was running a PowerShell, right, in your system with a -E, which means encrypted, and then they gave a command that's encrypted, right? I can't read this stuff. So again, as a digital forensics person, I go in here and I say, hey, look at this. Somebody was running a PowerShell with the -E, which tells me why are they encrypting this darn thing, right? And here's the string. Can I decrypt the string? Can any of you guys decrypt the string? If you know how it was encrypted. Has anybody ever heard of a tool called CyberChef? Some of you may have, right? CyberChef is a Swiss Army knife for anyone that does digital forensics, okay? So what is CyberChef? Let me go up here. I have a browser running, okay? I have a tab called CyberChef. All you have to do is go search for CyberChef in Google. And this is a free tool. And what I'm going to do is, so CyberChef has an input over here and an output. This is where you put your encrypted stuff or any text that you want to encrypt or decrypt. And then here's the recipe that you put together, and here's the output. So what am I going to do? I'm going to go in here. I'm going to grab that entire string. I'm going to copy that entire string. Okay, I'm going to copy it. Okay, and now I'm going to go to CyberChef and I'm going to put the string in there. Okay, I don't have a recipe yet, so the output is identical to the input, right? I don't know what it says. Now, on the left-hand side over here, okay, I have a whole bunch of operations that are already done for you. Now, with experience and with looking at multiple strings that are encrypted, you start to get to see patterns. It's kind of sad when you start seeing patterns in encrypted strings, to be honest with you. But when you see the capital J, capital A, capital B at the beginning of something, this tells me that this probably came from a base 64. Okay, so what am I going to do in here? I'm going to take the from base 64 and I'm going to drag this to my recipe. I'm going to say, let's take that and let's decrypt that with the from base 64 algorithm. Hey, this starts to look a little bit more that I can read this a little bit, right? When I look at this, the first thing I see, by the way, that little line that you can barely see there, it says null. Okay, so guess what I'm going to do next? I'm going to remove all the null bytes out of this darn thing, right? So I can, there's a ton, by the way, there's a ton of different recipes in here, and you can string them all together, and you can play with them, and you can change them around. So if you're ever decrypting something, CyberChef is like one of the best tools that you can possibly play with. So I'm going to look for remove null bytes. I'm going to add that to my recipe. So now the recipe is going to run things in that order. From base 64, now we're going to remove the null bytes. So I went from this string to this string. Now when I look at this string, this is something that I can read now, right? And what's the first thing that I notice here? I start looking at this and I see an IP address. Okay, I have an IP address. This is cool. I can go, I have a trail, right? So I'm going to keep track of that IP address, right? I found an IP address right there. And I would say, you know, that came from a PowerShell command that was encrypted. And here's the encryption, and here's the actual IP address. So I'm going to keep track of that somewhere on my trail. Okay, so what am I going to do with this? Okay, so, I've already done this once, so I'm not gonna do it like, again from scratch, but there is let me clear this, okay? One of the things that I can do, I'm going to run, Windows.netscan again. Oop, I put the dot, I have an IP address now, so I'm gonna run Windows.netscan. Okay, and what I'm gonna do is I'm going to I'm gonna pipe it, and I'm gonna search for that IP address. And the IP address that I had was 196. What is the IP address that I have here? 192.168. So 192.168.144.129. .144.129. Oops. Okay, so let me see here. So I'm gonna run the NetScan. I'm gonna look for that particular IP address. Okay, so let me run that. So I'm following the trail, right? This is what I found from a PowerShell that was encrypted. And now I'm scanning to see if there's anything interesting in here. All right, well, what do I find? NetScan, remember, gives you a whole bunch of IP addresses. What I found was there's this process called svchost.exe that's associated with the IP address that I just found in CyberChef. And so what's one of the things that I get as output is this number in this particular column, 1488. 1488 is the process ID where this particular command was running. All right, so now I have the process ID. So I'm staying with my trail, right? So I have the process ID. What do I do with the process ID? Now, this has narrowed it down from the whole memory dump to one particular process in that entire memory dump. So can I keep narrowing this down? Okay, so what am I going to do from here? So one of the things that you can do is, I'm not going to run the whole thing here because it takes a little bit of time, but you can run the windows.dump files, okay? And you can give it the process ID of what you think is a problem. So you can run volatility with this particular plugin, windows.dump files. Here's the process ID of what I care. So what happens now is volatility is going to dump just that information associated with that process. Okay, I've already done this. Okay, and so if you look at my my dump files over here, I already dumped this file. And its process ID, this is what happens when you run that previous command. I'm not going to run it, but it dumps this particular file. I have process ID 1488.dmp. What kind of file is this? So I can run the file command on Linux, and this tells me the type of information that's in here. So let me look at, which directory I'm on. I'm going to cd dumps. Okay. Here, file star. Okay, and so this is file 1488. It says thermocan, raw data, whole bunch of information, sensor temperature. Who knows what the hell this thing is? But I can read it with a regular editor. Something interesting in here. Okay, so I have the dump of the file. So what am I going to do? There's another command that you can run. And I only wanted the command that does all of the dump files is also going to give me, let me cd. Remember what 1488 was attached to, right? In the previous command, it was attached to svchost. So the dump file commands also outputted the svc host.exe file for me. Okay, so I've gone from the entire memory thing. I've run a whole bunch of plugins. I figure out that there was one command, a PowerShell command that was encrypted. I decrypted the string using CyberChef. They gave me an IP address. I went back to Volatility. Volatility said, hey, Clem, it looks like this particular IP address is associated with this file called svc host.exe. We use the dump files command, and I end up dumping this svc host.exe file that was running in that process. What do I do with that file now? Right? Okay, so this is where all of this stuff is really fun. So what can I do? Have any of you ever heard of the tool called VirusTotal? Okay, VirusTotal is a website. You can pay a lot of money for this, but there's a free version. And what you can do is you can provide a file, a URL, or some other information in here and upload it. And it will tell you, does it look like this file contains any malware? So anytime you guys download anything to your computer, I would always suggest using VirusTotal, because you can upload that file into VirusTotal and it will tell you, do I think this thing has any malware or not? So I'm going to go in here and I'm going to say, I'm going to choose a file and I'm going to look at, I'm home here. The file that we just dumped was svchost.exe from Volatility. I'm going to open that and I'm going to run it. And guess what? These are all the companies that have information on that particular file. And these companies, they all seem to agree that there's a Trojan associated with that particular file. So that's really cool. That already tells me that it looks like there's a Trojan associated with that file, right? So the encrypted command that was being run associated with an IP address allowed us to go all the way down to dumping that particular file from that memory capture. We put the file into VirusTotal, and VirusTotal is telling me that this looks like it has a Trojan in it. So now we're getting to, we're understanding the process, right? We're putting together the digital forensics associated with what happened in this particular situation. Okay. All right. Any questions on this so far? Okay. I think this is pretty cool, right? That's digital forensics. You're tying the knot between all the different nodes and you're following a digital trail to get to what happened. Yes.
How often is VirusTotal updated?
VirusTotal, the community updates VirusTotal, and each of these companies contribute information to it. VirusTotal is a really good place to go to. You can upload any file you want, and some of the files don't contain any malware on it, but there's a lot of information in here. So there's the detection information. This is the company associated with what they found. Not everybody finds stuff on it. Here's a whole bunch of companies that didn't detect the Trojan in it, right? So it's up to you to make that decision. If there's only one company that detects a Trojan, for me, that's enough not to download that into a computer or to bring it into a sensitive area, right? But there's a lot of other information that's provided for you here. You can look at the details associated with that particular file. It gives you all the different encryptions and hash values, creation time, everything associated that it can extract from that particular file. Yes?
What's the purpose of detecting the Trojan?
Now you know that this is probably one of the potential malwares that had that infected that computer or did something to a computer, right? So like MSU was attacked with a ransomware attack like April 20th at I think whatever the pot date is. I don't know what that is. So April something, April 20th or something. I don't know when it is. At 4:20 in the morning, right? And so what happens, right? The National Guard came in and the FBI came into MSU. And what do? They go to all the different computers and they do some digital forensics, hard disk, as well as memory forensics. And with the memory forensics, they don't just use Volatility. There's a lot of other tools out there, but they can start, this is the type of work that they do in digital forensics. They start following the trail, right? Until they find, hey, we found a file that appears to have had a Trojan. Does that mean that this is the reason something occurred? Maybe not. Maybe it was just an infected file that was there, but it's one of the flags that we add in there, right? All right, so there's a whole bunch of additional information that's in here. It's up to you guys to take a look at this. There's different associations of the files. Here's some of the known contacted IP addresses associated with this particular file. So there's lots of possible things that you can look at. Yeah.
Stored somewhere?
The file, at the very beginning, there's a little button that says upload, and it brings up a window, and you can just,
After upload, are they stored somewhere?
they store a lot of metadata information, and so they have like a giant database that's constantly being uploaded. Now, VirusTotal, I used it in my lab, but we needed to they have an API with this as well. So if you're checking tens of thousands of files at a time, I'm not going to be doing this manually, right? So you call the API, and of course they start charging you, if you're checking 10,000 files a day, now they charge you a certain amount of money, right? But for any one of us that's using, that you have your computer at home, before you download anything, right? Or if you download it before you run it, before you open that DMK package or whatever, put it on VirusTotal. It takes 2 minutes, and it'll tell you whether it has a known malware or not. Okay, it takes 2 minutes. Okay, we're gonna take a break, 10-minute break, and then we'll come back and do another set of exercises, and we should be able to finish up fairly quickly. Okay, so hopefully I don't bore you with all the slides, but I think it's important just to at least at a very high level, tell you what, there's the theory and there's the hands-on, right, for digital forensics. But so all of the investigations and incidents, they do have a defined process in this particular field. So ACPO is the Association of Chief Police Officers, and they typically provide the guidelines that are still kind of the Bible for how you actually handle digital forensics and how you handle this. You can also go to if you're doing cybersecurity, you know what the NIST 800 documents, there's a whole set of documents, the NIST 800 that are relevant to what you do. The 61R2 is what focuses on digital forensics. And so you can go and take a look at practices and the different techniques and how do you do a response, when you have an incident. So this is part of the 800 series. And at a very high level, this is what you're going to see, right? You're going to prepare, and you have a set of tools that you use. And in some cases, there are spreadsheets using a PowerPoint spreadsheet. It's just the way in which it's formatted to keep track of what's going on. There's the detection and analysis, and there's different ways in which you go about this. We talked a little bit in general about how you do that. There's the containment, eradication, and recovery of the process. Who has what's the chain of custody of the digital forensics. And then you end up doing also a post-mortem or post-incident activity report, right? And this is just like everything else, right? This is kind of like a life cycle of how you do this iterative process within that process itself. So nothing new in here. So the preparation itself, right? You have to know who the contact information is. Who are the on-call people for the information? What are the mechanisms that you're going to use for incident reporting? And again, you have to follow the standards to do this, because if you want to make this admissible in a court of law, you have to follow certain standards. Judges that are aware of and that handle these types of cases, they're going to not admit something that hasn't followed the proper protocols or procedures. Okay. Their issue tracking system. There's what is the encryption software or decryption software that you've used. CyberChef is one of them, right? And I can say, you have a war room. Most companies that do digital forensics have a war room, and they try to keep segregated the different incidents that they're working on. The last thing you want to do is keep different cases and use the same directory to store different cases. They're very, very diligent and very organized about how they separate each of these cases. Okay, storage facilities. So what is you guys, if you've done, not digital forensics, but cyber, you know what the attack life cycles looks like, right? You have the network perimeter below the line, right? And you have the internal processes in here, internal threats are coming from here. 80% of attacks, right, on companies come from internal threats or internal actors, right? But there's the potential for external threats as well. Somebody who's coming in from the outside, who's being, looking at your company, trying to get information from the garbage dumps and from your website and from talking to your employees. Eventually, they find a way to get in, right? So this is existing access, perimeter compromise. They can escalate privileges, and then they can do reconnaissance, remain dormant for as long as they want to, right? They move laterally, they give each other authentication permissions. And then there's two things they can do. They can exfiltrate data to a C2, right? A command and control IP address, for example, or they can disrupt businesses. They can do all sorts of things, right? But this is a high level view of your attack lifecycle. Okay. What are the attack vectors? Removable media, web-based attacks, email attacks, impersonation, improper usage, loss of theft. It's all sorts of ways in which you can attack, right? What are the signs of an incident, right? The web server logs indicate the presence of unauthorized vulnerability scanning. If you have a system administrator at your organization or at the company that you're working on, the number one question you ask the system administrator today, or your CISO at a company, the Chief Information Security Officer, is, are all the logs for your Windows or Linux systems in your organization turned on? If you're not logging information, you're potentially losing information on anybody that's potentially trying to access your organization. You always have somebody looking at your logs. And so actually, let me see if I can show you. There's actually, okay, so let's go back to here. And this, again, it's going to take a couple of seconds to readjust. Let me see. Yeah, this is going to take because it runs on the cloud. One sec. One of the plugins. Okay, here we go. So one of the plugins that's also your friend. And again, I'm sorry, this just automatically reverted to what we had before. But let me clear the screen. Okay, so let me bring up Python again. Okay. So there is a plugin called Windows.FileScan. Okay, and if you're working on a Windows environment, you know that we're going to search for EVTX. Okay, EVTX files are basically your Windows files. They're in XML format, and they're event log Windows files. Okay, a lot of Windows systems files that are formatted like this. And so if you run this particular plugin and you just grab for EVTX, okay, from the memory dump, it's going to go and see if there's any information associated with those files in this particular computer. So if your system administrator is doing due diligence and they're allowing for logging to happen in your organization, right, then this is just the EVTX files. There's lots more log files. Remember, I just grabbed for those files here. There's lots of other log files, but all the EVTX files that are listed here, Windows System 32, right, Microsoft Windows, here's one of the log files, another log file, another log file. There's a ton of them in here. This is one of the places where you go to as well to see if anybody did anything at any particular time. Most logs have timestamps associated with things. So what am I going to do with the information that I just showed before the break? There was an IP address associated with that particular file that was a Trojan. I'm probably going to go and write a script. And these are tools that are already written, right? And I'm going to say, search through all of these log files and look for that particular IP address. if you find an IP address in one of these particular files, give me that information, and you'll probably tell me, when did this person start the process of accessing the system? When did they run a command? When did they try again? Sometimes one of the first clues that tells me that something is wrong is when you open a log file and you see multiple failed attempts at something, and then eventually one success. That tells you that, you know, what's going on here. It's not just one failed attempt, but, you know, 100. Somebody's using a bot or something to try and access that particular system, okay? And you can do that by scanning all of the log files, which are provided to you with one of the plugins in volatility, okay? So let me go back to where we were before. And I have my slide somewhere. There we are. Okay, so indicators of compromise. You're going to have alerts from an NIDS or an HIDS, right? Suspicious log audit entries for some of the key services, configuration changes in your system, multiple attempts that have failed. These are all things that you can look at from your log files. So different types of analysis, right? You're going to profile your network systems. You always want to baseline normal behavior. What is it that my system, you know, is supposed to be doing all the time? When you're looking at a log file for a particular tool that you use all the time, you know what's being logged on that all the time. When you see something slightly different, that's when you know something's wrong. There's a lot of tools available that capture information that's that deviates from the expected behavior. We use a lot of regular expressions to capture those patterns, and we can look at all these different files. We write the regular expressions for rules, and we look for those rule violations. That gives you an indication that something is going on. There's a lot of different ways in which you can do analysis. I'm not going to go through all of them. There's also documentation, right? You want to document the status of the incident, summary of the incident, indicators, actions taken, so the chain of custody. This again all goes back to the process of doing the digital forensics. You also do prioritization, right? You want to know, you want to prioritize the incidents to see which one is critical. There's different ways in which you do this. There's functional impacts, right? What is the impact of the incident on the IT systems? There's information impact. What is the impact on the confidentiality, integrity? You know, maybe there's no impact to your organization, but they stole a whole bunch of PII from your company, right? So that probably has a higher impact. And then recoverability, right? What is the size of the incident, degree of the compromise? You know, how does it affect your company, not just monetarily, but reputation-wise, right? So you want to look at all of those things. So you prioritize depending on what's important to you. And then, of course, there's the due diligence of notifying all of your shareholders if something was stolen, personal information, you're required to do that. Containment, it's also part of the process, right? You're going to contain the strategies. You're going to turn off certain systems. You're going to pull the plug on many systems if you think something's going on. There's all sorts of different techniques. All of this should be documented in an organization that follows the proper procedures. In other words, this shouldn't be, hey, we got attacked, what do we do next? We got attacked, and here's the steps that you follow, and you do it all in order without deviating from that particular system, and you practice that over and over. So really large companies, when I worked for HP, we had a list of things and steps that we took. If something were to happen, we didn't question it, we didn't ask, we didn't try to triage, we didn't try to figure it out. That was for after. Initially, you just follow the steps, you pull the plug here, you pull the plug there, you run this tool, you bring the backup here, and then you're done. And then you go back and try to figure out, okay, what happened? How do we recover without compromising another system? That's when you start doing that particular work. But that should be in place as soon as you get to an organization. You shouldn't have to figure out how to do that when the event happens. Okay. All right. Yeah.
So you hear about like honeypots. Is that
Yeah.
a good method that like the companies use that to try and detect if people are trying to tackle?
So some companies use honeypots. I never saw honeypots being used at like at HP or Intel. I never saw that. This is more people who are really trying to understand what are the forms of attack or different, ways and a lot of, what 90% of the stuff you catch in honeypots is bots. And so there isn't a ton of information that you get from them, at least from what I've learned. And not only that, but a lot of the bad actors that are out there, they already know that there's a whole bunch of honeypots out there. And so it's kind of, it works and it doesn't work. Now, if for any of you who ever thought about putting a honeypot, which is, a honeypot is, a way to spoof someone or to get somebody to come to you. And you already know that they're gonna try and do something nefarious to your system, and so you catch them, right? You have to be careful if you're doing any work like that. There's a fine line between defensive and offensive cybersecurity. And so when you're putting honeypots in place, you're technically doing offensive work because you're trying to catch somebody, you need permission. So we tried to set up a honeypot at MSU a while ago. We needed the FBI to review what we were trying to do.
Oh, so that's federally regulated.
It's federally regulated because it's considered offensive. So an offensive, what you're trying to catch somebody, right? And so you're not defending anything. You're purposely going, trying to lure somebody to see what they're trying to do. So you just have to be careful. I'm not saying you can't do it, right? But be careful when you do it, right? So, all right. Analysis, I already covered this, eradication and recovery. So there's a whole bunch of lessons learned, right? What happened when. This is all part of the process of documenting everything that you're doing when you're doing digital forensics, okay? And then the final part is the post-incident analysis, right? You prioritize incidents, go through all of the process, and you do that. Okay, so let's go back and let's do another, let me do another example here. Okay. This will come back again. So, okay. Let me see if I can, I do not know if I'm gonna make this bigger, but maybe I can. Nope, it's not allowing me to. All right. All right, so what is the next thing that we're gonna try here? All right, so let me run Python 3. We're gonna run volatility 3 again. We're gonna run it on a different lab that I have here. This lab I didn't give to you guys, and the reason I didn't is because it's huge, the memory capture, it's huge. Some of you may have been able to download it, lab 2. Did some of you download lab 2? Okay, for some of you it did download, for some it didn't. I do not know what the storage was on the virtual machine that you guys have or what you guys have. And so in some cases, it didn't download, but it doesn't matter. We're gonna go through it here. So we're gonna look at lab 2 and let me look at, let's see what the name of the file is. Okay. Okay, so. Let's see. Okay, so I'm gonna use this file, copy it. This is a different, this is a different memory dump. And what I'm gonna do here is, I'm gonna run Windows, not malfind. Okay, so what is malfind? This is another, malfind is another plugin that I can run. And malfind says, is there anything in this particular memory dump, any process that I recognize as potentially having malware on it? right? And so volatility is constantly updating a lot of these things, right? And so this is the first thing that I'm always going to run when I'm doing digital forensics on a memory dump is I'm going to run malfind because it gives me hints, okay? Now, malfind outputs a whole bunch of information. And so what I want to do is I only want to capture the lines, and I'm going to grep here. So I'm only going to capture the lines that contain this string, bad DS. Bad DS is a variable address, virtual address space for that particular process, because that's the line that contains the information that I want. It gives you a whole bunch of other information that you can run it if you want, but all I care about is those lines that contain variable address space. See, this is the VADS string. That's what I care about. So when I look at this, VADS, by the way, is a data structure. It's the data structure that is used to store this information when you have processes running on Windows. Okay, it's just the name of the data structure. It contains a whole bunch of information. It just so happens that the output of malfind puts out so much information, but what I care about is that particular line for two reasons. One, it gives me the authorization value in here. Anytime you see page execute read write, that means the process is readable and writable. And as a hint, and again, you're not going to know this until you start doing this for a number of years, that tells me that these particular processes that have execute read write are primed for code injection. Okay, just about 99% of code injection targets have this page execute read write flag associated with that process. And so you wouldn't know that until somebody else tells you, or until you've been doing this for many, many years. And then the other part is, what is the name of the files that appear to be flagged by volatility on this memory dump? So here, my hint is, hey, Outlook has been flagged, Explorer has been flagged, SVC host has been flagged, and this thing called Skype C2 has been flagged. Okay, now, how do we know what's bad or what's not bad, or where do I go first? You don't. You just know that these are all hints that you got from the tool. And so what I can do is I can go one by one and start examining these files after I dump them, or I rely on my experience and I say, hey, how can I know where potential attacks are going to happen? Now, I'm not going to go through every file in here, but one of the things that you find, one of the things that stands out, and you would know this over time, one of the things that stands out here is this command called Skype C2 auto update. Okay, and this stands out only because why would I have Skype auto update on its own unless you configured it that way? Not only that, but even the name C2 smells of something weird, right? C2 means command and control. And again, this is kind of doctored, right, for the class, but for the workshop. But you would go through this and you would say, you know, that looks kind of weird. So what is it that we can do with this? One of the things that I can do, okay, the first thing I'm going to do is I look at this and I see, hey, there's the process ID associated with that particular file. So what am I going to do next? I'm going to go off and I'm going to dump from that memory capture. I'm just going to dump that part of the memory capture because I want to explore that. Okay. And so how do you do that? The way you do that is you do a windows.mem map, and then you give it the dump, and then the process ID, and I'm not going to run it here because I don't want it to take forever, but then you run that particular plugin that says dump that process associated with 1364. Then it's going to dump that process for you. Yeah, I'm not going to run it here because I already have it, right? So if I list I already did this before the class, and there's 1364. Okay, I already dumped it. Okay, so there's 1364. And so what am I gonna do with that thing now? I'm gonna go ahead and I'm gonna, remember when I look at this, there's a whole bunch of files here, but I wanna dump the files associated with this particular process. Now that I have the process dumped over here, I want to dump the files inside that particular process. So again, I'm following the trail, right? Memory, I'm going to dump the process. I want to dump all the files associated with that particular process. When I do that, I use you guys remember, I use the Windows dot dump files. The dump files plugin. Again, I'm not going to run it here for the sake of time, but what happens is you end up with a whole bunch of files. Now, since I'm not going to run it, clear this. Okay, I already dumped some of those files. I already dumped that file, and here it is. The process 1364 img.exe. When you run the plugin, you actually get a whole bunch of files that get dumped for you, right? You have to sift through all of those files, and you get to see, you kind of over a period of time, you get to know, oh, this is an Outlook file, this is a PST file that you can upload into a viewer or calendar viewer. This is an executable file. And so you start getting better at identifying some of the files. And so what I did here is I only dumped, I have this particular file that I think it's interesting. Again, I'm just, showing you guys what I had. So what I'm going to do next is, if I had 1364, what's another thing that I can do here? I can run the netscan command. This is what gives me IP addresses, right? And I can grep for that 1364, for that process ID. So let's see what I get. So I'm going to do a netscan. Remember, netscan gives me IP addresses. Is there an IP address associated with this 1364? So when I start looking at 1364, there's the Skype C2 auto update. This is 1364. And when I look at this, here's an IP address that keeps popping up. Skype C2, and here's the IP address that pops up. Okay, so I have an IP address. Again, I'm going to keep reiterating this. We're only doing some very minimal digital forensics, but what we're following the trail. We have the image, we get the process, we get the files associated with the process. Now that I have the file or the processes, is there an IP address associated with this particular file or process? We found one, right? So we have this 54, 174, 131, 235. What can we do with this thing? Okay, so I'm going to, since we dumped that process 1364 already, let's see if the IP address is inside that particular process. Okay, so one way in which you can do this, there's a command in Unix, you've already seen it, the grep command. -A says, I'm going to look inside a file that contains binary information. It's not ASCII. So it's all, all the weird characters. And so the -A allows me to look into that. So I'm going to look for the IP address, which was 54.174.131.235. I'm going to look for that in the file. Let me look for it in the dump file first, in the dumps PID.1364.dump. Let's see if we find anything in here. So there's a whole bunch of, you can see that there's a whole bunch of weird characters in here, but grep -A still can get anything that's printable in there. There's also another command in Linux, if you guys have ever played with strings. There's a command called strings, and you can download strings, and you can also look for things using the strings command. But what you can do is you start looking for things in here. And one of the things that's really interesting when I started looking at this, I'm gonna scroll up a little bit. And I know you guys can't see everything, but if I start scrolling up here, okay, in this particular place, and this wasn't a huge output, I was able to get the output. In here, there's the IP address, TP, that tells me that's probably HTTP, okay? So that's what I would look for. And then it says getinfo.php. So all you have to do is go Google what getinfo does. And getinfo is really a command that you can pass in a URL to send information back and forth with something. So this tells me that Skype C2 update is probably communicating with this particular IP address and is sending information. So this is the command and control. So somebody out there is talking to this Skype process, communicating and getting information. Again, I'm following the trail. All right, so I found that information. What do I do next? I'm gonna go ahead and so you have that information. Oh, well, what was another thing that I saw? What was another thing that I saw in there? In the malfind output. So if you look at the output, let's follow another one just so you guys can see. Let's look at the malfind. Okay, we're gonna run malfind again. Move it up a little bit. Okay, so we search for one. So this looks like a command and control. Somebody's sending information back and forth to that IP address, but there's also an Outlook in here. Outlook, the reason I'm suspicious about Outlook is because what does Outlook do? It's an email system. And where do most attacks occur? Is when somebody's fishing for information, or right? So immediately I'm gonna say, I'm gonna look at Outlook. Okay, I'm gonna just for the kick of it. And so when I look at the output, I'm gonna look for the process ID. 2692, 2692, 2692, 2692. That's the process ID I'm interested in. So I'm gonna go on dump again from the memory image. I'm gonna go and dump that process 2692 so that I can explore that 2692. I already did that, right? So I'm gonna show you, I used the dump file, I used the memory map, dump the process ID 2692. And so if you see I already did that before this started. And so here's the 2692 dump that I have. So what am I gonna do with this thing? All right, I'm gonna say, let me see where I am there. I'm gonna do a grep minus A because it's binary, okay? If this is an Outlook, if I'm looking for something that Outlook did, how do I know, how do you search for whatever somebody sent you? What string would you search for in an email? What's that?
Your email address?
Your email address, but who's sending you the email from? Right? So I could probably search for from. So what am I gonna do in here? I'm gonna search for from, colon, maybe space. Okay, I'm gonna search for from, who's sending the emails associated with this particular process. And I'm gonna look in dot dumps, PID 2692 dot dump. Well, let's see what that yields first, right? So I'm gonna search that. After searching the entire file, look what I find. Right? It looks like that process, right, contains information about a from line that says Karen Miller at t online.deutschland, whatever, right? Somebody's sending the email probably from there. So, okay, so now I have an email address. Who is this person? Okay, so what am I gonna do next? I'm gonna go ahead and dump all of the files associated with this particular process over here, because there's something interesting about this person, this Karen Miles. So let's go ahead and dump everything associated with that particular file. And one of the things that I did is, let me show you guys. Where's my dumps? Where's my file dumps? I put them in here somewhere. This is memory capture file dumps. I already dumped a whole bunch of these files, so I didn't have to do it here. All right, so let me clear this. Okay, so what I did is I run the dump files plugin, and I said output all of the different files that that are associated with this process ID that contained Karen Miles or whatever it was. This list is much bigger than this. Okay, there were 274 files that got dumped. What I did is I kept only those files that had the string PST on it. Okay, there's a string called PST, and sometimes it's called the OST string. Okay, these are PST and OST file that end in PST or OST files are Outlook files or calendar files. Okay, so it's like, okay, so now I have a whole bunch of Outlook information, right? Some of them don't have the .pst at the end, and so you have to rename those files and add the .pst at the end so that I can now read them. So how do I read these files? Well, there happens to be something like CyberChef for reading email files. Somebody figured that out. So if we go in here, okay, there is a tool called Goldfinch PST Viewer. This is free, okay? And the Goldfinch PST Viewer, and you can Google Goldfinch, allows you for free. You can, of course, pay to get more information. You can open a PST or an OST file here for free. I've dumped all of these PST files from what I think is a nefarious, Karen Miles or whatever. So I'm going to open one of these things. So this goes to the directory that I have all of those files that I dumped because they end in .pst. Okay, now you have to go through every one of them to see if there's anything interesting here. That's, it takes forever to do this when you have 200 of those. Now, I already went through this, right? So I'm going to pick one of them here. I'm going to open it. So what happens when you open that? The left-hand side here is going to list the file that I just opened that I dumped from that process. Okay, you can extend that, and you're going to see that I have one calendar and 2 suggested contacts in here. Okay, what can I do with this? You can go to the calendar. There's an eCoin meetings, and there is a suggested contacts, and sometimes you can read these things, sometimes you can't. So let me see if I can read this. Nope, doesn't let me, there's nothing there. That one, nope. That one, eCoin meetings. No, it's not allowing me to do much. So what am I going to do? I'm going to go back and search for more stuff. Let's open another one. Let's go to this Philip Price guy. It looks really interesting. So let's just pick one. Okay, let's pick the first one up there. All right. So let's see what this one has. This one looks more interesting. Right now I have 15 inbox messages and 4 sent from this person. All right. So if I go to the inbox, what do I see in here? I have a whole bunch of emails sent to Philip Price, right? This is his email. There's one in here that looks interesting, ransom request, right? And there's another one that says eCoin invoice, right? I don't know about you, but I would look maybe at the eCoin invoice. If you're lucky, you were able to capture the attached file. You can download the attached file, and maybe what do I do with the attached file? I'll probably run it through VirusTotal, see if VirusTotal has any interesting information on it, or see if there's any additional information in here. Why do I care about this one? Look at who sent it. Karen Miles. Okay, so now I'm putting together the strings and it's saying, hey, Karen Miles was flagged as somebody who was in a potentially malicious process that was flagged by Malfine in volatility. And I was able to download one of the Outlook files that contains her in a from command that has a bank statement associated for an eCoin potential malware request. You know, there you are. And you're following that thread, right? You get into that spot, right? Fun stuff. Not every email looks like this. I made the mistake in my class. I had one of the emails that students opened that had a whole bunch of 4-letter words on it. Well, guess what? That's the real world, right? And most emails, and that was between the CEO and the employee that who the ransom request was sent to. And of course, the CEO had a lot of choice 4-letter words to that particular employee, and all the students got to see the email. But that's the real world, right? I'm not going to sanitize that, but that's what happens, right? And so that's an example of following that digital trail on how you guys do this. Now, I don't expect you guys to, you know, to take away from this particular workshop every little thing and all the commands and all that. I will make all of this available to James, and he will be able to distribute all the commands as I run them right here. So if you guys want to run them, you can. But the idea is that this is how digital forensics works, right? There is a process that you need to think about that is associated with the law that says if you don't follow that, you're not going to be able to, you know, this won't be admissible in a court of law. You have to follow the process. You have to be super diligent about the order in which you do things, how you record it. And then you have to know and be diligent about what are the tools that are available for you. There's a lot of tools that are already there. You don't have to figure them out. We saw CyberChef, right? That allows you to play around with decrypting messages that potentially came from a PowerShell that was an encrypted parameter. We have tools like VirusTotal that can already identify potentially malicious DLLs, executables, right? Shared libraries. We have tools that allow you to open up PST files that you can dump from volatility, and you can see what some of the messages say. So there's a whole bunch of, and some of them are available, some are not. Here's another one. But there you go. Okay. Sorry, but this is what came out of this, right? This is the real world, right? And so you're reading emails as they happen, and this is the stuff that occurs in digital forensics. When I work with my students in digital forensics, I have the students sign an MOU that says you will see some stuff that may not be what you want to see. And it's not just words, but sometimes you see images, and sometimes there's videos. There's a lot of bad people out there. You have to have the stomach to be able to see that, right? And that's unfortunate, but you know, there's a lot of bad people. So, but this is what you see, and this is what you get to play with. Okay. Any questions on this? Because I think that's as much as I can. I don't want to go through the rest. The rest of the slides I'm going to share with you, and the rest of the slides are basically just finishing up on what we had here. And I'm, you know, I don't think you guys are. I think you guys are getting the gist of what we're trying to do here, right? There's different models, okay, that are out there for doing investigations. And some of these models, it's just like software development life cycles that you look at. You know, you take a software engineering class and they teach you about prescriptive processes, agile, sec DevOps, all these things. There's different processes that are out there for conducting investigations that follow a prescribed approach to doing things. Most of them seem to follow similar approaches. I'm not going to get into this, but this is just part of the theory behind doing some of the digital forensics and what you guys get to do. And so, and the rest of the slides are just really all about, you know, how you distill the information, how you prepare the information, surveys, how you preserve evidence. And we've covered a lot of this, the scoping, and I'm not going to go into all of that because it's just details and I don't want to put you guys to sleep. I think it's more fun to see how things happen, you know, in the real world. And that's what you guys got to see here. So any questions? I don't have any more, you guys. You know, I'm super happy. Want to go through the slides. So we're 2 hours and 10 minutes. So, hopefully that's, any questions? Would anybody want to be a digital forensics person after seeing all of this? Would you? Yeah, I mean, it's really good pay, but it's a lot of tedious work too, right? What, you guys saw like the fun part here, right? The hard part is sitting through this for hours and hours until you put the dots together. Right? Now, there are tools and you wouldn't be doing this from scratch. You know, you have your recipe and you say run malfind first, run ps list second, dump the files here, run this tool, you know. So you have already all the recipes in front of you. But when you finally find the answers and you find the evidence and you find who's doing something, it's really fun. So
And speaking of the tediousness or the repetitiveness of some of those tasks, is there, or are there people doing research into automating that using
Yeah.
maybe machine learning or something?
there's a lot of AI going on right now to try and match things and to facilitate the process of doing this, but it's not even close to being admissible in court.
Okay.
Because the intuition behind the human is not there yet. You know, AI for me, I'm sorry for anybody who does AI or machine learning, but AI is nothing more than algorithms with tricks. That's all it is. Okay, machines cannot think, they will never be able to think. It's just statistics. That's all it is. And we minimize stuff, we classify stuff, but it's statistics. That's all it is. So, you know, so no, I don't think it's a long time before they'll admit any of this AI techniques, you know, in court, but they certainly facilitate minimizing the error from narrowing the answer to looking at things, right? So it's a heuristic. That's the AI part, the heuristic. All right, yeah.
Okay.
Yeah,
Regarding your comment with the AI, are we still at the point where we might be able to use some system to find something like that Trojan horse?
sure.
But as you said, that may just be a corrupted file that might not actually be.
It could be, right. So what are computers good at? Searching lots of spaces, big spaces. So that's what computers are good at, right? They do it fast. The AI allows you to search a space with a heuristic, focus on this part of the space. You use different techniques to narrow the space, right? Regression techniques, neural networks, you know, genetic algorithms, you jump when you get stuck in minimums or maximums, searching a space. But once you get to that part, it's part of the human intuition to be able to figure that out, right? So yeah, I'm not a big, I mean, I love AI, don't get me wrong, I use it, but it's a tool. And it's just a computer program that's calculating values. That's all it is. It's nothing.
When you talking about the log files earlier and
Yeah.
making sure that you're always collecting those, it seems like at a big company like HP here or someplace, if you're monitoring every machine in the company, these log files are gonna become a very big data set very
They're
quickly.
huge. Yeah,
So,
they, after a certain period of time, they cut them, they tail them, basically, that's what they call it, they tail it. And they start getting rid of things that are older than a certain amount of time. And then, but they still keep some of them in perpetuity, only if the information is necessary, if there wasn't ever a trail or something like that. So, but yeah, pretty fun stuff, so, yeah.
Are there like a decent amount of like internship opportunities for something like this, or is it
So-
more like entry level?
No, there's a lot of, there are internship opportunities, so I work with a company called Blackthorn directly, and, one of their consultants helps me teach this class, because he's a hands-on, real digital forensics. I'm not a real digital, I'm not doing this every day, right? I just know how to do some of this stuff, but I don't do it every day. So these are guys who are doing this every day, 24 hours a day. And their company hires 2 of our students every year to do digital forensics as interns in their company. And they teach them from the very beginning how to do these things. Some of them focus on the cloud, some on network, some volatile, you know. But if you brand yourself as a digital forensics enthusiast in your LinkedIn account or something like that, you're gonna get some interesting calls. because there aren't many people who want to focus on digital forensics. It's just not, again, it's not the CSI part of the story. 99% of this is like really, but it's not for, I mean, I think it's fascinating when you eventually find the right answer or you can pinpoint something. And so to me, the reward is huge. So to each its own, right? I don't know. But that's what I would do. If you're really interested in this, there are courses that go into this forensics, memory forensics, and then start looking at the companies that are doing this. Microsoft has a team of people that do digital forensics. They're one of the worst in the industry, and they have a very small team. And there are a lot of other companies who are amazing at doing digital forensics who dedicate themselves to just doing digital forensics. So you get what you pay for, right? So the free tier is going to be the Microsoft team sends a guy a month after the fact to see what happened. The platinum tier, they're going to send a group of 10 people. They're going to work with local enforcement agency in your local area, and they're going to count hours after an incident occurs at your organization. And you're going to pay for it. So it depends on what, like everything else in life, right? Get what you pay for. Anything else, you guys? All right, you're gonna move the extra time today.